Okay, let's solve the equation that results from setting f of x equal to m of x. All right, this one will be the most complicated one that we have because the roots don't match up. All right, we have a square root on the left and we have a fourth root on the right. Okay, but luckily they're both even. So working this out is not that difficult, although it is going to be a little bit of a challenge. Okay, so let's think about this for a second. Think about this in the way that you normally would think about fractions. Okay, if you want to get rid of a fraction, you multiply both sides by the common denominator. This is really what's at play here. This is an understood 2. This is a 4. The common multiple would be 4. Okay, we'd multiply, or not multiply, but we're going to raise both sides to the 4th power. Okay, and I'm really going to expand this a little bit to help us see what's going on. Okay, so the left side is going to be the interesting side. The right side is boring. That's just going to be 1 minus x, okay, because the 4th root and the 4th power will cancel each other out. On the left side, though, let's think about what's happening. This is really, or you at least can think about this, as the square root of x plus 5 squared times the square root of x plus 5 squared. Right? Think about that for a second. You have a total, scoot that over a little bit, you have a total exponent of 4, so you can break that up into 2 and 2. The reason why that's convenient is because in those cases, the square root and the square cancels out, the square root and the square cancels out, to leave me with x plus 5 times x plus 5 equals 1 minus x, where that comes from there and that comes from there. Okay, we have 2 sets because we raised to the 4th power, so we're going to have more than what we need on the left side. Okay, well, at this point though, although it's a little bit more complicated, we can work this out. Let's do the distributive property here. We're going to, let me see if I can maybe clean that up a little bit. Let's distribute, deciding on my colors here, distribute the x. That's x squared plus 5x. Distribute the 5, that's going to be 5x plus 25. And that's all going to equal 1 minus x. Okay, it's a quadratic equation. At least we know how to solve quadratic equations. All right, so let's combine like terms first of all. That's going to give me 10x. So x squared plus 10x plus 25 equals 1 minus x. Now to solve a quadratic, we have to get that right side equal to 0, or at least one side equal to 0. So I'm going to add x to both sides to cancel out that x. I'm going to subtract 1 from both sides to cancel out that 1. And that leaves me with x squared plus 11x plus 24 equals 0. Okay, I can factor this because what times what gives me 24 but adds up to 11? That's going to be 8 and 3. 8 times 3 is 24. 8 plus 3 is 11. So it factors as x plus 8 times x plus 3. Set these individually equal to 0. And that gives me -8 and -3. Again, these are potential answers. I need to go back and plug them in to make sure that they actually work. Okay, so I'll go back to my original problem here. It's going to be the square root of x plus 5. Write it down. The square root of x plus 5 equals the 4th root of 1 minus x. Okay, let's plug them in. Starting with -8. So no colors this time. -8 plus 5 is equal to the 4th root of 1 minus -8. That's going to give me the square root of -3 is equal to the 4th root of 9. Okay, now we have to think about this 4th root of 9 business. But I don't have to continue working this out to see that this is not going to work. Okay, this is not going to work because a negative under the square root is going to give me an imaginary number here, not an imaginary number here. Okay, so we're going to go ahead and call this one without stressing ourselves out too much about simplifying this and say that negative 8 is no good. Okay, let's try negative 3. So negative 3 plus 5 equals the fourth root of 1 minus negative 3. Well, negative 3 plus 5 is 2, so that's the square root of 2. Minus a negative 3 is plus 3, so that's going to be the fourth root of 4. Okay, so now the roots are kind of weird, so these might actually be equal to the same thing. Let's kind of experiment a little bit to figure it out, and that's where I'm going to throw in the idea of fraction exponents. Okay, so 2 to the 1/2 power is the same thing as the square root of 2. And 4 to the 1/4 power is the same thing as the fourth root of 4. Okay, well, think about for a second that 4 can be rewritten as 2 squared. So this is the same thing as 2 squared to the 1/4 power. But whenever you raise an exponent to another exponent, you have to multiply them together. So 2 times 1/4 is 1/2. So they actually come out to be the same thing. 2 to the 1/2 power. I know, that was a little bit complicated, but they're the same, which means that I do have a solution, and that solution is negative 3.